We will go over the properties of exponents in this video, and we'll try to work on the problems that combine all of them. So we'll start off with the product property, and we need to know the basic vocabulary for exponents, right? We need to know the idea that this thing right here is called the base, okay? And the number that we put up in the air is the exponent. So we'll be talking about that, okay? So we can see that in this problem, we have these bases are both x. So if you're multiplying two variables and we have the same base, then that means that we can add the exponents, okay? And the reason that this is true is because it's basically the definition, right? This is what we want this to mean. So if I did x squared times x cubed, well, x squared means x times x, right? Two of them. And x cubed means x times x times x, three of them. And so in total, there's 5 x's. So rather than write all of these x's, we could see, what if this said 20 and that said 30? Would you want to write all those x's? That would be ridiculous, right? So we have a way to count them, and we would know that we would just get 50 instead, and we would realize that writing them like that would be useless in this point, right? It's too much to write. So that's why we want to use these rules, okay? To save time, to save writing and stuff like that, right? So this rule right here is called the product property, product rule, all right, product property of exponents, all right? But that's the basic one, and everything else is based on this one. Let's go talk about the power rule. All right, the power rule looks kind of like this, all right? If we had something like x squared to the third, we want to figure out what this means, all right? If you did this the wrong way, you might think that this is 2 plus 3, all right? But that's not true. Okay, we can't have that. That's not the way this actually works, okay? What x squared cubed, what does that really mean, right? It means write what I have in the parentheses 3 times. So I'm not going to write x squared 1 time, but I'm going to write it this many times, right? 3 times. We got x squared times x squared times x squared. And what this means, again, right, is x times x times x times x. And like I said, the whole point is to avoid writing all of these numbers, right? We need to know that we can just count them all up. So if I add up 2 plus 2 plus 2, we would have 6. All right, it's another way to do it. So we see that in this case, what's our power rule? All right, the power rule looks like this. So we got x to the a to the power of b, and that's the same thing as x to the power of a times b. Okay, and you can see that 2 times 3 gave us 6, right? So again, that is called the power property. All right, so power rule, power property. Okay, now we're going to get the quotient rule, quotient property, however you want to call it. We are going to get the last one, and then we'll talk about negative exponents. So this one looks like this. All right, we got x over a, sorry, x to the a over x to the b. And we want to understand that what this means is a, x to the power of a minus b. Okay, so notice that the number that's on bottom is the one that I subtract. That's the one that's getting taken away. So why is this true? I mean, we could do a couple examples. If we got x to the 5th over x squared, what this means again, right, is I got 5 x's on top, all multiplying, and on bottom, I got 2 x's. So if I cancel 2 of them, we see I have 3 left. So think about it, like I minused 2, right? Because I took away 2 that were on the bottom. And so that's why another way of looking at this, right, would be x to the 5 minus 2, and that's just x to the 3. Okay, and either way, we have the same idea. All right, the last idea we're going to go over now is the idea of a negative exponent. All right, so the definition of x to the negative 1 is 1 over x. Okay, but we could do some more examples to make sure you get my point. X to the negative 2 is 1 over x squared. X to the negative 3 is 1 over x cubed. Okay? So negative exponents, typically, if you guys look at your worksheets, right, you guys will notice in the directions, the key word is that it says it should contain only positive exponents. All right? If it didn't say that, then maybe you could leave it the way it is. But it says only positive. So if I give you something like this, and I want to write it in only positive exponents, then I have to make it into 1 over x to the 4. Okay? So let's talk more about this idea of negative exponents and how it works, right? Another idea that's essential that you guys understand is this, okay? A to the b, a over b to the negative 1 is like b over a, okay? So the negative 1 power just means flip it over. So I just take the fraction and flip it. So a over b becomes b over a. All right, if I had something else though like this, right? A over b to the negative 2. Well, now what should I do, right? Well, I could apply the whole negative 1 thing and flip it over first. So if I flip the fraction over and make it b over a, now that's not negative 1 anymore, and that's not negative 2. Now it's just a positive 2. And now I could basically be done, okay? So I could try to do this in more steps, but I feel like it's really just going to confuse you more, all right? But I can't help but try to be technically showing everything. So let's try this. What I'm trying to make my point right now is that we talked about the product rule, yeah? Remember that? Okay? And we know that negative 2 is the same thing as negative 1 times 2. So think about what we got, right? I just told you guys up here that a negative 1, right, means flip the fraction over. So look, that's a to the b to the negative 1. So I just flip it over, and then it's squared still. Okay, you see my point? So to apply that operation of the negative exponent just means to flip the fraction. But now we're going to get to the most complicated idea. Okay, it's what happens when we have negatives in the fraction already, and they're all over the place, and we have chaos, right? So we'll take a look at something like this. All right, let's say we got a to the negative 1, b to the negative 2, c to the negative 3, x to the negative 1, y to the negative 5, and then z to the negative 2. All right? Which one of these things is going to stay where they are? And the answer is none of them, right? Because they all have negative exponents, and because your paper says to only have positive exponents, that means everything has to move. So all of the ones that are on bottom will be on top, and all the ones on top will be on bottom, but they'll have the opposite sign. So I have a to the 1, b to the 2, and c to the 3, x to the 1, y to the 5, and z to the 2. Okay? So it's that first idea, right? Like I was trying to put these into words, all right? The way that I've been kind of saying the steps for this kind of problem has been move and flip, okay? When you have a negative exponent, that means you're going to have to move and flip. So let's put a little negative exponent I guess we'll just put process, all right? For lack of a better word right now, all right? So the first thing that I tell everybody, move and flip, okay? So I'm going to use this, and you're going to understand what that means while we do some examples, all right? Move and flip. And then after that, what we're going to do is we're going to combine, okay? And the last step is to cancel. And that's where we'll get rid of some things, all right? So if you can see this example that we did up here, we only had to move and flip, right? We moved all the negatives to the other side, and we flipped the sign from negative to positive. So let's do another couple examples. Let me grab something from your homework. Okay, I don't want to do too many examples, but let's start with the big one. Okay, and like I was telling my students with these problems, the rules are so simple that if we ask you them in isolation, you guys will be fine. But the second that we combine all of them, then it becomes like alphabet soup, and you guys don't necessarily know what to do, right? So we're going to attack this problem right now. I'm just double checking that I didn't make any mistakes. It looks good. Okay. So we go to our process. Move and flip. All right, let's talk about what move and flip means, okay? So So when I say move and flip, I mean to take anything that has a negative exponent, for instance, this x to the negative 4, right? That's a negative exponent, so it has to move to the other side of the fraction. It cannot stay where it is. It's got to go somewhere, okay? But then we got to talk about the difference, right? What's the difference between this and this? Okay? In this example down here, the 2 is taken to a negative power. But in this example right here, the 2 is not taken to a negative power. Okay? So my point that I'm trying to make is that this term needs to move, the x to the negative 4. But the 2 is going to stay right there because the 2 doesn't have a negative exponent. So let's move and flip so you guys can see what I'm talking about. Here we go. The idea is, okay, I can start at the top. Let's just start at the top so we can talk about it. So 2, all right, that's a positive 2, and it has an invisible exponent of 1, okay, so it's going to stay where it is, all right. Now we look at the y to the negative 5th, okay, that's a negative, so it has to move to the other side of the fraction, okay. This is an x cubed, that's positive, so it can stay, okay. That's a y to the power of 0, so that's really just times 1. Then we have x to the negative 3. That has to move then. Again, the negative exponent is going to move, so we're going to go bring an x and make it a positive 3. Then we have y to the negative 3. That has to move also, because it's a negative exponent. Okay? Now we made it to the bottom. The 2 can't move, okay, but this x is to the negative 4, so I have to move it to the other side and make it a positive. So now we moved and we flipped. Everything is positive, so we're done flipping signs. Now all we have to do is combine and cancel things. So we'll take a look at the top here. We got 2, and you can see we have x cubed and x4. So that should give you x to the power of 7. On bottom here we have the 2. Okay, and we can see that we have y to the 5th and y to the 3rd. So that would give us y to the 8th. And then we have x to the 3rd. That'll stay right there. When we cancel things in our third step, right, remember, move, flip, combine, and now we're going to cancel. So we can cancel the 2's. Okay, there's no other y's on top, so those are going to stay the same. But look, there's 7 x's, and we can get rid of 3 of them, right? So what's going to be left? Okay, that means that we'll have x to the 4th on top, and on bottom, we'll have y to the 8th. Again, because that's 7 minus 3 that we would cancel out. Okay, so at some point, you got to do a little bit of this in your head. If you try to show every step, it's going to kind of drive you crazy. But again, we're counting. So counting has to happen in your head. So don't try to show too much work, but you're going to have to write. There's no other way around these problems, right? You're going to have to write, start moving things around. Just understand we're moving and flipping, which means that you got to write something. So you want to start writing symbols and moving them as soon as possible. That's the way these problems work. All right, we'll do another couple ones. When we look at this example, it has no variables and only numbers. And so let's take a look at these ideas that I'm trying to emphasize. All right, we want to move and flip. All right. Is the mantra I'm trying to give my students here. Move and flip, and then after that we got combine and cancel. Okay, so move and flip, combine and cancel, and that should get you to the end. So as we work through it, we're going to start out by applying the rules, okay, which shows us that really we have an extra step before move and flip, right? And that means that you might have to simplify, and this is up to you, so you have to use your discretion. Sometimes you might want to move and flip and then simplify. Other times you might want to simplify and then move and flip everything, because that'll be like a neater process. So make your mind up. In this case, I want to simplify first, okay? So I want to multiply this negative 4 out here against these 2 exponents, okay? And that's going to make like a cleaner, it's going to get rid of the parentheses and everything, all right? So we have 2 to the negative 1, but negative 1 times negative 4 makes positive 4, right? And 4 times 0 is still going to give me 2 to the 0. Okay, and on bottom, when I multiply 4 times 3, right, because we have the power rule, that gives me 2 to the negative 12. Okay, Well, like we said, we've now simplified. So now we can take a look at moving and flipping. So by move and flip, what I mean is that if something, right, if a base has a negative exponent, you have to move that term to the other side of the fraction and make it positive. So on top, we have 2 times 4, right? And then 2 to the 0 is just 1. Anything to the 0 power is 1, right? Okay, but now we're going to move that 2 to the negative 12. We're going to move that to the top, and we're going to change the negative to a positive because we moved it. And notice that there's nothing left on the bottom, okay? There's nothing left on bottom. We could think of it as an invisible 1, I guess, okay? Or we could just think of it as going away, right? There's nothing else left on bottom. So our final answer is just going to be right here. We got 2 to the 4 times 1 times 2 to the 12. And so we do the product property, and we combine the exponents. We get 2 to the 16. So I wish you luck, all of my juniors out there in Math 3. All right, good luck, you guys. Let me know if you got questions, all right? Good luck.